For some reason, I went to Elixir EU in Berlin. I think it was 2016. And there were wonderful speakers there, one of them sitting right here, and their enthusiasm really made me want to join this community too. So thank you for anybody who spoke there. I came away from that full of excitement for Elixir and the ecosystem. And I was working in a company where I really felt it would be a good fit. So it's an IoT company, which is connected devices. We had embedded devices, so there's nerves and stuff like that. So I really wanted to use Elixir. And if we look at this picture, so what is IoT? Internet of Things. So everything in this picture, which is electrical, like this, this signal device, the points, the lights, the traffic lights, anything, usually have their own networks, so they can be monitored and stuff like that. With the internet, all those isolated networks can be joined together, and whereas these things used to just transmit their state, now they can receive commands as well. So I was working for this IoT company. They had a platform, and one of their customers came to them, and they made large industrial heaters, but also commercial heaters as well. So, the heaters that heat this building or run the air conditioning systems, stuff like that. They wanted to sell a service to us or the people that own this building. If, say, there's a heat wave coming, they can predict that, and they can reduce, say, the temperature in this room by a degree. We wouldn't notice, or something like that. So, the proposition is, they save us money, and we save oil, burning oil and gas and stuff like that. But they're a manufacturing company, so they had their own bespoke cloud, but that's not their core competence. And I was working for a company that had an IoT cloud, an offering, so it seemed like a very good partnership. We take over their cloud, we run it for them, they carry on making stuff. It seems like a good business fit. So what's this talk going to be about? So just a quick talk about the domain, what the electricity grid is, what is supply and demand, where our power comes from, what the customer wanted from this, what I built, me and my very small team of 2, how we system tested it, how we load tested it, and then did they buy it. So this was pitched as an advanced talk. It's not as advanced as Johanna's talk or Mikhail's talk that's coming up next. This is more going to be an overview of why Elixir is excellent for IoT. It's not going to be a deep dive. Okay, so first of all, what is the power grid? We all have batteries now, so there's kind of a barrier between us and our power supply. But anything you use in the real world is connected via copper to huge spinning machinery. And you probably know that there's a frequency on the power supply. It's 50 hertz here, it's 60 hertz in America and half of Japan. If that frequency range deviates, equipment starts failing and exploding. So there are people in rooms, like, if we all turned our laptop on, someone would notice and they'll make little adjustments, okay? So this is this awfully colored website is gridwatch.co.uk, but the data is really good. So this is the demands that we in this country are placing on our grid. And sometimes these weird things happen. Like, I don't know what happened at 3 o'clock. Maybe it was a hot day, everyone went home early. If there's Wimbledon on, you'd have the opposite. You'll have a peak, okay? So these are the demands we, in our lifestyles, are putting on the grid. This is how the supply meets that demand. And the supply must meet the demand. Otherwise, again, things start exploding or burning out. And so you can see when I took this, it was a sunny day. So we've got nearly 4 gigawatts from solar of a demand of 30. But solar comes and goes. Clouds move across the sky. The wind rises and falls. So you need a steady base load, which is provided by nuclear. Nuclear, if you turn off a nuclear power plant, it takes 2 weeks to turn it on again, so you don't want to do that. So a lot of these supplies fluctuate, and a lot of them aren't renewable. So a lot of the power is delivered by burning gas, and there's only so much gas in the ground, and there's only so much oil, and there's no coal burning at the moment, but during the winter we're still burning coal. This is at night time. You see solar's gone away, and we need to replenish that. I mentioned the frequency. So if this frequency deviates by more than half a hertz, then you're in problems, right? So we need to keep, again, the supply and the demand matched very accurately. So this business proposition is demand response. So there are people actively maintaining the supply to match the demand, but now everything's connected. We can now also match the demand to the supply. These aren't turbines. If there are any older British people in the room, if you ever dialed 123 to set your clock, set the time, so the voice is encoded in these grooves here. So that's one of this is like 60s technology or something like that. But turbines look like that when they blow up. Okay, so if we deviate too far, we get blackouts, which we want to avoid. So I've covered that. So what did the customer want? So they wanted a demand response solution. So that was their new business proposition. They wanted to prove they could connect to 100,000 devices, because obviously the more devices, the more of impact you can make, environmentally and stuff like that. They wanted to scale their product range. They wanted to bring new products to market. So I'm going to use the word scale a lot in this talk. They wanted monitoring and metrics, obviously, like the charts we just saw, and they wanted ease of administration. They wanted a portal, a product, basically. So what does the business domain look like? It's not too fuzzy. So there's a facility like this place. There's heaters in this place. There's a control panel somewhere, maybe on the wall. That's all connected to a Wi-Fi hub, which is going to talk to our cloud. This is what we built. And then there's people that administrate the cloud. And then, so the new entity in this relationship is DR partners, so the demand response partners. They would take in feeds from, weather, news events, maybe, the trains have stopped running, something like that. They'll make decisions and feed controls to us, and then we need to send that information back to all these devices. So we need a reliable system, and what's better than Elixir? It's built on Erlang, which is telecoms grade technology. So how would you model this? So there's been discussions, quite often when people start Elixir, every module becomes a process. Like a user logged in, that's a process, and the book they buy is a process, and that's kind of an anti-pattern, but which has been covered in other previous talks. But what I find is, in the IoT space, anything that's a real thing in the real world is a process. That works really well, and I have never had to move away from that. So, like the control panel in this room, that's a process. The heater downstairs, all that. So that's the center box. So that is how we modeled this. So everything in the real world is mirrored with a gen server. And then I said we don't want to lose, if I'm sending a piece of information, your boiler's about to explode, turn off, we don't want to lose this stuff. So I can't keep everything in memory in the gen server. So we have a durable message store as well. We used Influx for our time series database, very nice little database. And we have our IoT platform that I mentioned earlier, which was part of our core offering. I'll skip over this a little bit. So all the messages were binary, and I was just able to take the specification from their Word document, just basically paste it into Elixir, and it does all the parsing of the messages. Again, I won't go into any too detail here because this has been covered in some previous talks now. But that was very easy to do, very impressed. So the devices connect to our cloud via Cowboy. So we need to send, one thing I forgot to mention, so the company, they had old generation devices and new generation. The old devices are very passive. They connect to us, but you need to ask them everything. How hot are you? What firmware version are you? Are you about to explode? Blah, blah, blah. So we had to poll those. The new world was more pub sub. They connect to us, but they tell us things, okay? So there's two worlds here. So this is the old world. So for every connected device, I need to keep a list of all the commands I'm going to send it. And these things, they had a bus, and you could only have one message on its bus at a time. So I needed to manage all that and store that in the state. And I'll get back to why that's important a bit later. And when I send it a message, when I get a reply, I can't parse that reply without knowing what the request was because the format doesn't have enough detail to explain how to parse it. So I needed to keep what the request is that I sent it before I could parse the reply, and I'll get on to why that's important later. Okay, so how did we... So we built a prototype very quickly. I was amazed how little code it was. It was like 300 lines to do all the protocol, another 300 lines for all the gen servers or something. Very simple, and that's without hooking up to the databases. How to test? We'll just skip over this a little bit because I have a bit of... obviously, we use property-based testing. So what is the model for the system? We have entities that just generate key value data, right? That's all they do. They read the temperature of the room, they send it to us. So how do we model that? Well, we can just keep a hash map, just a normal Elixir map of the last versions we've received. And for the time series database, that would be a list of values. So our tests were literally, we had mock devices that generate known sequences via this Erlang library called trick. And then we would play that through the system, and then I would call the API saying, what's the current state of this device? Does it match the map I've made? This was all covered in a talk by John Hughes in Lambda Days in February this year, so I just recommend that. I'm kind of glossing over it a bit. And then the other one is ask the time series database, have I lost any data in transit, through all these gen servers? So that is how we tested it, basically. And one mistake people can make in property-based testing is, well, I have a temperature, it's just a float. But if you ever get into a situation where your tests are failing, you don't want your tests to explore the whole domain of a float, 0.1, 0.001, 0.002. So what this does is, well, if I'm generating a temperature, well, if I can't send a 0 through the system, then I might as well give up, So what this line is saying, most of the time I'll choose a 0 or 1, and then later I'll choose a reasonable temperature for a room, and then I'll do ints, and then I'll do floats. And then, so a request would be, generally I'll ask, is there an alarm, or is there a water heater temperature? There's 100 properties, so I've really cut this down, but then I might throw in some random requests, and then just for the hell of it, well, let's throw in some binaries as well, because, is my parser going to fall over and things like that? So this is how I proved to myself and to the team that Elixir was a good fit for this. Here's the output of some of this. You see there's some good messages and some garbage messages. So this is how I proved that I'd done all the pattern matching correctly and stuff like that. How do we test it? So I need to test with 40,000 devices. So we set up the mocks in various data centers around the US, and we all connected them to our cloud. And then there's a really nice tool called Gatling, which is a DSL for load testing. And you can, so the devices are the mocks are testing the devices, and then the Gatling is testing the users, like the administrators, hitting it. So I'm hitting it from both sides. So that tool Gatling was really, really good. And I'll come back to the database shards at the end. Right, how many servers do I need? It's 100,000 devices. So, okay, well let's just run one and see how many devices I can put on one server, and then I can just divide that into 100,000. Then I know how many servers. So we did the load test. And so this is 40,000 on one server. Now, you wouldn't want to run a server this hot, because if it disconnects, you get a thundering herd, and you don't want to be running hot servers, but I can do it. There was a discussion in Slack yesterday. Someone said, when can I use distributed Erlang? Well, I mean, do you need to yet? This is a lot of traffic. And the reason all these red bars is this is plain Ubuntu. The packets I was talking about, they're less than 1K, and Ubuntu's not great for sending lots of small packets around. So if I'd have done this in FreeBSD, it might be a little less red, and the green would be the same. Okay. So I know there's things like Basho have this technology for distributed hashing. So, okay, well then I can have 4 servers, and then I can intelligently route, the request to the right server where that device gen server is running. But then, well, hang on, I have a production line. These devices are 100,000, right? There's going to be no viral surges of traffic. So, well, let's look at the production line schedule, and then I know how many servers I need to run. But that just, But that sounded like a lot of work, so let's just get a bigger server. Okay, so I just got the biggest server Amazon had, like reasonable one. Okay, I can do 100,000 on one server. Okay, that's fine. It's fine for a proof of concept, yeah? I mean, you wouldn't run it. But it meant I got to throw out all that, the distributed stuff. But remember, I'm trying to sell this into the company. Okay, so did they buy? Did I answer all the exam questions of the customer? So I was impressed, and the guy I was working with impressed. This was my second Elixir project. So I'm impressed, and I'm still here 3 years later, so I'm very happy with Elixir. My colleague who never used Elixir really liked it. The team were like, well, we can scale. You know, I can do this in Node, I can do this in Java. Yeah. So they were like, oh yeah, engineers, fine, we can do this. The customer, now this is, the customer, right, they already had a bespoke system, so we're giving them another bespoke system, so that would be an awkward conversation to have, okay? And they're buying a product. I don't have a product, so I still have to integrate it with the dashboard we already have. Okay, we could build a new Phoenix app, but there seems to be a gap in the market for that, like for a commoditized IoT solution. So the customer weren't really interested in having it, so we had to integrate their stuff with our cloud. There's a problem with our cloud. It's been proven to scale out horizontally, fantastic, but it's stateless. So a lot of you might know this quote. I think we should invent the same quote for Erlang. So if you build a distributed system, right, and you don't use Erlang or Elixir, you're going to end up building OTP in whatever you choose, yeah, unless you're using Akka. And the guy who wrote Akka only wrote Akka because he couldn't use Erlang, right? So this model is so good for this space. So yeah, so we had a stateless system. So remember what I was saying, all my communications were state. I needed a list of messages I'm going to send to the device. Well, the administrator might add a message to the queue, and the device might add a message to the queue, but my API doesn't have a transaction. So I'm like reading, adding to a message to a queue and putting it back. So then you have a race condition, right? Okay, so we need to handle that problem. Let's check my notes on this. Sorry. Yeah, so that's the race conditions. So we're implementing IoT. Well, what data have I received? So I needed to know what I sent so I could parse it. Well, that's on disk somewhere, just do our cloud. So every time we sent a message, it's a disk write. Every time we receive a message, it's a disk write. That message may have business implications, and all those may handle other business writes. So that sharded database I showed you just got really, really hot. Everything we were doing was hitting disk. So this comes down to scaling, so that when the customer said they couldn't scale, they're talking about product line. When the development team heard scale, they're thinking, oh, well, we can scale because we're stateless. So we've all been in conversations where we're annoyed because the other party aren't quite getting what we're saying, and I've just come across this really interesting principle. If you have false in any design or in any logical argument, everything built on top of that either falls apart or you need to paper over it many, many, many times. So when you're in a team, you really need to listen to the vocabulary your team are using and try and identify, does everyone have a common understanding of the words they're using? Because if they don't, you end up building something that's almost not fit for purpose. We built it and it worked, but it was a lot harder than it needed to be. And that's covered in this book. There's a type called absurd. If you ever have the absurd type in your business model, it means your whole model is you can throw it out the window. So that's, I know I'm out of time, but yeah, do use Elixir for IoT. It's really well suited. I'm still in contact with this customer, and I'm hoping they're going to come back and say, oh, we'd really like to use Elixir, but for right now, they're not using it in this space, but hopefully they'll come back to us. So that's it.